Today we're going to be doing 9.5. This is week 8. And on this specific lesson, we're going to be using this website. So make sure that you click on this website and are able to follow along with things that we do on the website, because you're also going to use this for the assignment as well. We've used this website before in one of the previous weeks, so you should be able to be familiar with it. But we're going to also be using this to doing more of the calculations rather than doing graphing this time. So I'll be doing this actually right away. So to get into the first part here, this is actually kind of the warm-up problem. We're going to be using this website to fill in this chart here, the XY chart, and we're going to be graphing the y equals 10 to the x. But we're not actually going to look at the graph, we're just going to fill in the chart to answer the question below. So I'm going to go to that website now and just going to type y equals 10, and then you have to hit Shift 6. That gives you the caret button. So you can see the cursor's up a little higher, x. So we already know what this graph looks like. It's an exponential function. It's going to go up really quickly. I'm going to click on these three dots and go to table of values. This might ask you like where you want to start and end. So if it does that, as soon as you click on this, since I already did it, you're going to have to put in -3 to 4. So table of values, it's going to ask me -3 to 4. Hit OK. A step is fine at 1. So I'm just going to copy these numbers over, and then I'll be able to fill in the rest of this table here. So we have 0.001, 0.01, 0.1, 1, 10, 100, 1,000, 10,000. So hopefully you can kind of see the pattern here. We're just going to keep increasing by putting an extra 0 at the end here as we increase the x values. So the next one would be, for number 5, it would be 100,000. And so on. That's what 10 to the x power does. Estimate the x value using the chart. So what if we said we wanted this power, when we plug it in, to be around 23,900? Well, if we look at our table here, 10 to what power gives you 23,900? If you look at the table, none of them, because they all go by powers of 10, 100, 1,000. But what we can do by looking at the table is we could say that x is going to be in between two numbers as the power. If we look at the fourth power, x to the fourth, you get 10,000. That's not quite high enough, but it is close enough to the next number, which is 5, at 100,000. So we know that if we use 4, we get 10,000. If we use 5, we get 100,000. So it has to be somewhere in between the numbers 4 and 5. Now it's probably going to be closer to 4 because 23,900 is closer to 10,000 than it is 100,000. So it might be something like 4.1 or 4.2, something like that. So what we're going to be doing today is kind of looking at how do you solve something that has the x in the power as an exponent when it doesn't come out to be nice like this. How do we deal with something like this? We can bring up a table and kind of guess, but how do we get an exact answer? 10 to what power exactly gives you the 23,900? And the way we do that is something called logarithms. So for today's question, we're going to be linking exponential equations. We've been talking about them this chapter. We talked about exponential growth and decay. So how are exponential equations and logarithm and logarithm equations related? So it is a new word. You're not really familiar with that, but I'll show you what it means as we go through. Example 1. Solve for either x in your head or by guessing and checking. So if you're confused with how to do this, we're trying to think of what number, 2 to what power, gives you 32. Now, if you have your exponent table, you could use that as well and be able to figure out that way. Actually, I might be able to pull up the exponent table. Let me try to do that. The one we're doing right now is 2 to the what power gives you 32. So if you want to look at it, it would be 2. You find this over here, and then go to 32. That is the 5th power. Although you might have already known that. So we can say that x is 5, because 2 to the 5th power gives you 32. Part B. 6 to what power gives you 216? Same thing. You can look at the chart. 6 to what power gives you 216? Third over here. 6. Go across. 216 is the 3rd power. So that means x would equal 3. 5 to what power gives you 0? 5 to what power gives you 0? So let's see if we can find that on there. 5 gives you 0. It's actually not possible. We don't see a number on here. It's not possible. The only thing we're missing on here really is 5 to the 1st power, but we know what that is. That's 5. So this is not possible. You cannot raise 5 to any power to get 0. 7 to what power gives you 7? Hopefully you can figure that out. That has to be 1. All right, so what about getting some fractions here? What causes this to go 1 over 81 rather than just being 81? First, let's think about how do you get 9 to what power gives you 81? Well, that would be 9 times 9, right? So if this said 9 to what power gives you just 81, we would say that's 2. 9 squared is 81. But in order to make this a fraction like it is, the only thing we have to do, if we remember, to make it flip around like that is just make it negative. So we can say x equals negative 2. And this should be consistent with the chart too, as far as getting the number 81. On the chart, we don't have negative exponents to use, so it will only give you the positive ones. Same thing for part F. 3 to what power gives you 1 over 27? Well, to get 27, we would need 3 to the, what gives you 27? That'd be 3rd power. So it's not 3, it is negative 3. All right, G, 4 to what power gives you 4096? Look at the table. 4096 is 6. So that's x equals 6. And the last one, now we're starting with a fraction, and it's getting flipped to just a whole number. So it's going to be the same idea. If you go from a fraction to a whole or back the other way, we need a negative number. So think about this as being 3 to what power gives you 9? Well, that'd be 3 squared, so x equals negative 2. You can also check these in the calculator as well. I was just trying to do these ones by hand or by using the table chart. So we are able to actually do these problems without using the table, and this is called logarithms. So how do we do these equations without guessing? You have to use something called a logarithm. Oh, I forgot my M. So what is a logarithm? I'm going to go through kind of how we use it to solve these equations, and then as we do more of these problems and get further into logarithms, you'll maybe slowly understand what they look like and how they're dealt with. But for now, it's just a basic introduction of what a logarithm is. Okay, suppose you have, what do we have? We'll say b to the x equals a. So this is just our exponential thing. B and a are just going to be numbers. Could be like 5 to the x equals 1,000, whatever it is, just like the problems we did up here. So then we say that x is the logarithm base b of a. And this is how you write it. X is a logarithm base b of a. We shorten it and just write log. Base B means it's like a it's called a subscript, which means it's a little lower than where the log is. You kind of put it lower like this. It's on its own level. Log base B. And then where it says of A, that actually goes back to the same level as the log and write A. So log and the A are on the same level when you write it. The B is kind of a smaller, kind of like an exponent, but it's on the bottom. It's below the log and below the A. It's kind of weird. You have to practice writing it correctly because you've probably never written something like this before. So these two things are actually the same. When you have an exponential form, b to the x equals a, that's the same exact thing. It's just rewritten differently as saying x equals log base b of a. And again, make sure you practice writing it correctly. Sometimes mine aren't perfect either. I just erase it a little bit and make it a little better. Base b, because it should be a little bit smaller than the log and the a part. So we're going to practice just going from one form to the other. We're going to start with something like this and go over there, or we'll start with this and go backwards. There will be numbers in here, not just letters like this. So we're going to practice doing this thing here. We don't need this. Example 2. I'll keep this up here as well. Rewrite the following equations using logarithms. So I'm going to practice going from the left-hand side over here to the right-hand side. So what do? We have 2 to the third equals 8, which is actually a true statement. 2 to the third is 8. We're just going to practice rewriting it using logs. So this means what? What would that mean? We start with the exponent. 3 is equal to log base. What's the base? In this case, it's 2. And then the a on the other side here is 8. So I know it looks weird, you're not really familiar with it, but we're just practicing how we're rewriting it. Okay, let's try it again. 4 squared equals 16. We start with the exponent here. We can say that 2 equals log, what's the base? That's going to be here, 4 of 16. And the last one here, start with the exponent, -3 equals log, what's the base? Is 5 of, that's going to be kind of hard to write, 1 over 125. Just practicing writing from one way to the other way. And you notice where the x is up here? That's where the x is over here. You just match the letters up. And then we write equals log all the time, then the b's match, and then finally the a's. That's all we're doing. So now we're going to practice going the other way. Rewrite the following logarithms using exponentials, and then we're going to be able to solve it. So log base 10 of 100 equals x. So if I'm going backwards here, up here, we're going to do, I think the easiest way to do this when we write it going the other way now is that we're going to start with the base number because we want to start with b and then kind of work our way around. So we're going to do b, which is 10. This is b right here. And what I do is kind of make a circle going around. So I'm going to do b, and then we're going to go to the x power. So I kind of go around and say it's b to the x equals, and then go backwards, 100. It's really easy to actually do this thing, the circle thing, because it just kind of go around it. You start with the base, go around to the other side, and then come back around. When we go to this form, you no longer have to write logs. Right? Only one form has the log written out. So if you start with logs, you don't end with them. If you don't start with logs, like up here, we didn't start with logs, then you end with logs in the answer. Right now we're changing this to exponential form as an exponent. B, do the same thing. Gotta go around circle. 2, start there, go around. That's your power. And then go backwards, 16. Logs are gone. Last one, 3 to this power, x equals 81. Now it does say after we rewrite it, we have to then solve it. So let's see if we can solve this. 10 to what power gives you 100? That would be the second power. 2 to what power gives you 16? That would be 4. If you don't know how to do that, you can look at your chart too. Don't forget the chart's still available. 2 to the 4th is 16. The last one, 3 to what power gives you 81? That would also be 4. So you may not be able to look at these original equations here and be able to solve them, but now you're able to rewrite it with exponential form, and then you can solve it. Actually, almost done. So I'm going to show you how to do this in the calculator as well on that website. For example, 4. Solve the following exponential equations by rewriting the equations using logarithms, and then we'll put it in the calculator. So right now, you can't really solve this the way it is without guessing and checking. You could say it's 3 to like probably 3.5 or 3.6. You could guess, but I'm going to show you how to put this in the calculator after we rewrite it with logs. So how do we do that again? If you forget, you can always just go back and look at the work you did previously, because we're going to go from here to here. So how do we do this? We say x, we start with the exponent, x equals log, so make sure you can do this yourself. What's the base? It's 3. And then that's of 45. This also kind of goes in a circle. You start with the exponent, right? X, and then it equals log of the 3, and then you go around this way, equals 45. It starts on the left-hand side, then goes around the other side. So how do we solve this? Well, let's practice doing the rest of these, and then we'll put them in the calculator. 5 to the x equals 100. That would be x equals, start with the exponent, then we go log base 5 of, go to the other side, 100. The last one, this would be x equals log base 10 of 1004. Okay, let's put this in the calculator. I'm going to bring up that website. So right now we have the table up here. You want to actually click on calculator. And if you ever don't want, if you don't want this to show up, I think you can just click on these buttons here and hit delete. That way you can start fresh. If you click in the space here, you should see a calculator show up at the bottom. And what we're looking for is the log button, which is not underneath this. You have to change it to f of x. Now you can see a bunch of other symbols. We want to click on this log with, you see there's like a tiny box below it. That's going to say it's going to give us a spot to put the base in. So once you click on that, let's see which one I'm doing first. We're going to do the first one, which is log base 3 of 45. So I want to click on log. And I don't know if you can see, but there is a cursor right beside the log. And you can type 3. Then I'm going to move my cursor over, hitting the arrow. And I think we're doing 45. So you hit 45, and it'll give you your answer. Log base 3 of 45 is 3.46. We'll just go to 2 decimal places. So x equals 3.46. So you can do these in your calculator, like on your phone, except for the fact that I don't know how to do the base part. So your calculator phone probably looks like this in a sense. It usually only contains the log button. And sometimes you have to press the number, put the number in first. So like if I was going to do the one we did, I really can't because I don't know how to put the base in there. It doesn't do that. So I'll show you what that means in a second. But basically what I'm saying is you probably should use the website. because I don't think you can get to show up like this in your calculator on your phone or on your laptop. So just use the website to get these answers. So the next one was log base 5 of 100. So I can just go up there. Hopefully I can just change these. Click on it, change that to a 5, and then change this to 100. That would be 2.86. 2.86. And the last one, we got to do 10, log base 10 of 1004. Well, I already have 100 there, so I'd make it 1004 and change the base to 10. 3.0017. So I'll say 3.00. So that's kind of how you do it. You're starting with exponential form and going to something called logarithmic form. And then you're able to put it in the calculator and solve it. So that's what we're doing. We're changing from exponential form to logarithmic form. This is how they're related. You're able to go from one to the other. You can go back and forth. As long as you do it correctly, then you should be able to get the right answer. Let me go back and just talk real quick about this part C. 10 to what power gives you 1004? We did 10 to the x power in the warm-up part for this lesson today. So think about 10 to what power gives you 1004? Well, we know that 10 to the third power is 1000. So if we want to be just a little bit higher than that, it makes sense that it's actually 3.00. No, I think it was what, like 17. It kept going. So it's just a little higher than 3, but barely higher, right? So it does make sense. It does work if you put the numbers in correctly and you're able to rewrite this with logarithms. You could actually check any of these. You could do 5 to the 2.86 and you'll get close to 100. Now I know we're rounding it every time, so you may not get exactly 100, but you'll get something very close to it. Because a lot of these answers will have like a longer decimal. Okay, last thing for today. Since our number system is in base 10, like we count, by tens, we do the tenths, hundredths, when we do decimals, our number system is in base 10. Every place value is a base 10. So since we have that, we use logarithms. We say that log with a base 10 is the same thing as just writing log, which is kind of confusing. So whenever you use your calculator on your phone and it has just a log button, it's using base 10. So I'll give you an example. What your phone probably looks like is with just the log button, like I was mentioning before. Say I wanted to do log of, say 52, right? With this calculator, I have to type in the button 52, and then I hit the button log, and then you can see it's this long decimal, but up here it says, I don't know if you can see it, log 52. There's no base written out, nothing. That means it's doing log with a base of 10. So sometimes that's the only thing your calculator can do. Luckily, like the website and the graphing calculators we had in school, they can do the bases. So if no number is written in the base, then we assume that is base 10. So let's get an example here. Solve the following logarithms. Log of 10 would mean log base 10 of 10. So you can actually put it in either calculator you want. Log of 10, for this one, if I was going to use this calculator, I have to actually do 10, I'd write 10 first and then hit log. So you can see the answer is just 1. But I will also do it in the website to show you get the same thing. So I already have base 10 here. Let's just change this to a 10. It is 1. Gives you the same answer. So you don't have to write it out differently every time. You can just click the log button. And actually on the website, if you don't want to use the base at all for log base 10, they actually have a button here for log 10. I haven't used it, so I don't know what it looks like. So let me delete this one. If I click log 10, it just puts the 10 in there for you. So they don't have it written without the 10 at all on this particular calculator. So what's log of 0.1? That means you're going to do log base 10 of 0.1. That is -1. So I'll rewrite it. Log base 10 of 0.1. And that is -1. And the last one, log of 45. This means log base 10 of 45. So I can change this to a 45. 1.65. So I would practice using this and being able to type it in correctly. If you ever lose the stuff to click on, see I don't have my calculator stuff anymore, you can click on this very bottom left button. It looks like a keyboard, so you can type stuff. Make sure you go to the F of X button, not the 1, 2, 3, unless you're putting numbers in, but I just type the numbers in when we do it. So this one is kind of a newer lesson, and it's kind of going off the rails from what you're kind of used to, using a whole new concept. Let me know if you have any questions on it. Make sure you use the website when we go through this lesson and for the assignment as well. And I know it is kind of weird. It's going to take a while to understand. Maybe look at certain parts of the video again while you do the assignment. And then, again, you can email me or send me questions on Remind. And we'll see you next week.